Can you imagine that the totally integrated automation portal can generate visualizations itself solely based on its Step 7 program? That's what the new option package, Semantic Visualization Architect, or SiVArc, was designed for. Allow me to present this to you in the TIA portal. To do so, we need a control system, a human-machine interface, and an engineered HMI connection. In addition, we're of course going to need a runnable control program. What's more, in the library, we'll need the screen display elements generated by SiVArc. I'd like to show you how to create such an element using a navigation button as an example. We simply drag a button into our window, make it a bit bigger, and go to Plugins, where we find the SiVArc features and attributes, animation functions, and events. To then create the text in this button, we enter a SiVArc term. Basically, this term extracts the symbolic name from the data module and writes it into the button as text. To generate other different buttons, we must also enter a dynamic element, otherwise the program will continuously generate the same button. In this case, we take the same button, and in order for us to be able to find it again in the script, I write nav underline in front of it. In order for the button to now execute a function, I go to Events and engineer a click event. In our example, we want to open a screen display. So I get a screen activation event, enter the term again, and I can then access the screens because the screen displays that we generate will all have the same name. Here, I enter only a 0 because we are working with the names and not with the numbers of the screens. The button is already complete and ready to be used for SiVArc. Now, all we have to do is save it to the library and assign it a distinct, unique name in order not to lose track of what we have done. Now that we have created the button, we want to determine where the button is to be located in the display. A positioning function is provided for this purpose. To do so, all we need to do is start a simple square. We adjust the square to the size and form of the button we created. It serves simply as a placeholder. I no longer need the button, so I can delete it. Continuing to work with the square under the SiVArc properties, I can now go to Layout field and assign a group name. With this group name, I now create multiple layout placeholders from this first one. This means that whenever I generate a navigation button, this schematic workflow will be completed from top to bottom. I now save this to the library as well by simply moving the screen display and saving it with the layouts. The file folder location can be freely selected. We give it a short name, also in the interest of unique identification. Finally, we have to enhance the screen display to be able to generate it. Here are two steps that accomplish just that. I have to assign a name so that SiVArc writes a name onto it. I can do that just as well dynamically by the way of a term, as I did with the button, or by hard-coded entry simply by writing the name on it myself. I'm going to select the layout scheme by looking at the library under Screens, where the layout scheme is stored in my file folder. We can see here that another one is already prepared. So, we've completed the display for SiVArc. I now simply drag it over into the library under Screens. I no longer need the screen display either and can now delete it. We now have yet to create a link between the logic of the S7 program and the SiVArc generator. For this purpose, I have my screen rule editor, which ultimately creates the screen display rules. The first step is to select a trigger module. We need this module because we go through the Step 7 program. And when we then see a call-up display of this module, the rule is then executed. That means when I now see the plant section module, I of course also want to generate on the base screen the object that I just created, our navigation button. So I select the base screen here. and in this case would place it somewhere in the screen display, but we have defined the layouts. I therefore select the specific layout field group, and ultimately that is all we had to do, because now the buttons are generated under each other at the position that we just defined. Since one screen display is boring, we've already prepared a reference rules package for a further screen in order to show you what the program can do. That just about wraps things up with respect to the rules. The next step is the generation of SiVArc. To do so, I select the Comfort panel here at the top and click on Generate at the top. I confirm the generation action, and we see that it goes through the information, analyzes the program, compiles the screen displays, and creates the objects. And when it is finished, 3 screen displays suddenly appear. First, our base screen, which I just showed you, and the 2 other screens generated by the system. I'll now show you the result on the simulator. To do so, we'll logically have to compile it on the HMI system. The compilation has now been completed. I now start the simulator, but we are starting here with the tag simulator so that you can also see what actually happens on the screens. For this purpose, I've already prepared the variables that we want to use. We now see the generated screens that we have created with SiVArc. All elements here have been created respectively by SiVArc, and based on the figures you can see that these corresponding functions are interconnected and enabled. As you have seen here, with SiVArc, you can generate your visualization simply, quickly, and flexibly based on your Step 7 program. That's engineering efficiency with the TIA portal.